누르면 되죠? 네, 안녕하세요. 역시 원래 요 세션이 이게 영어 세션으로 돼 있어가지고 이게 레코드 되니까 제가 영어로 60분 떠들 생각이긴 한데 분위기가 이제 다 한국인분들이긴 해서 뭐 나중에 제가 한글 자막을 올려드릴 때는 뭐 할 테니까 네, 들으실 때 문제 듣도록 하겠습니다. 네, 그러면 시작을 좀 해보겠습니다. 오케이. So my name is Sigrid, and I'm working in Sion AI for deploy software engineering, which means that I'm just looking at somewhat the forward industries, like looking at the recent trends and to implement those into the concrete services and just exploring some of the features. And then my basic interest is to learn first and to how can I just connect those the concepts into have them deploy into concrete business models. So in this talk, I would like to cover about kind of how can I just deploy the RAGOps systems or its pipelines, or rather is talking about somewhat the machine learning models or the kind of related somewhat sophisticated features like kind of like manipulating its chunking strategies or the fine-tuning it's based on the data set. So I just wanted to focus on kind of real-world the use cases for like maintaining its pipelines, maintaining its RAGOps without kind of like very like painful operations when it comes to in the DevOps infrastructures. I really like this meme. Like Simpson comes up and to reiterate like writing on the chalkboard about its lessons about it. So I just recreated this meme. Like RAG is more than just embedding search. So when it comes to like in recent spaces, we're trying to implement those like AI like or LLM features into their business. They're talking about kind of RAG. So the reason why people are talking about RAG is something like they do not want to give pour the bunch of the money for the fine-tuning models to learn its relevant knowledge for the enterprises or the internal knowledges, but rather than to keep its really reasonable the solutions for like manipulating its in-context learning stuff for like retrieving its related context and related chunks, and to put up into the context to make sure that LLMs can like generate its answers based on the given context. So basically, like if we just encounter with like two like sentences, like if we like given a query from the users that why do T and the /T have different methods as the sets. So when it comes to like encountering with these questions, like users are expected to like find like relevant context. So this query is about kind of Go languages grammar context, right? So in that case, like it is expected to fetch the relevant passages from about Golang. Like so basically this query is from the Golang website about kind of frequent asked questions. So you would expect to find those like relevant passages from prefetched FAQ like passages, which is on your like vector database or this is somewhere like in the vector spaces, right? So basically, like people are talking about like vector database because like when it comes to like conducting an embedding search, like you need to like deal with kind of the embedding spaces and to find the methods to retrieve based on kind of like lexical searches or like other like embedding search methods. So like it is not something provided by the traditional databases. Like if you are like familiar with like working with like PostgreSQL, then you might be very easy to find how can I do in like full text search, like keyword-based search. But when it comes to like conducting a context aware search, then it's not something compatible with traditional databases. Well, there's some databases like the Postgres Factor. They have extensions for it, but at the same time, the people are talking about whether we should have dedicated vector database or not. So I will just try to cover up this on this talk. So let's talk about kind of the few considerations of vector database. So it is very familiar to see on the contestations about which vector database you should look into. So I just captured from the Reddit about, you have bunches of the available options, but there are very little benchmarks, and then there are little options to kind of compare. So basically you have a choices from Milvus or Quadrant or Weave8, but there is no kind of a silver bullet, I think. So it is based on kind of which vector database that you should consider based on the traffics, or which options that you might consider, or based on the amount of documents as well. So we can just think about vector embeddings as arrays of floats. So if you say you have 75 dimensions, then it doesn't mean that you have 756 elements, the number of elements itself on the list of the floats, which means that you should deal with a bunch of the floats. So it is just not confined to the single element of the float, but it depends on the amount of the document or the amount of the chunks that you have. So it goes very exponential. As you might have more documents, you need to deal with more floats. So the problem is how can we deal with these millions of the numbers of the floats? So let's talk about some imaginative examples. So let's say you have a numbers of represent as bytes on the disk. So you have 0x10, 0x 00, 00, 00. So these are the numbers represented as a byte on disk. And you can just think this of as kind of the Go data structure as a uint32, which is 16 bytes. And you might easily think of using the encoding binary libraries to parse into this the numbers on the disk, just read in the binary, and to just catch up some error if it happens to be. And you might be just easily end up with parsing the data structure using a binary encoding library, right? But the thing is, if you just take into these, the benchmarks, you might be able to find easily about kind of parsing the 1 billion uint, 64s takes around the 26 or 30 seconds if you take these benchmarks. So the when it comes to looking at kind of each benchmarks, the most of the starting point is about the memory allocations. So you might see, you might be easily to see about this malloc GCs, which means that it takes around 7 or 8 seconds, and you might think to moving over memory using its runtime itself takes around 6 or 7 seconds, which takes up 24 or 25 seconds. So we just need to reiterate about this data structure, very early lessons on taken on the computer science class in the first class. There's a stack or heap, and we all know that stack is so much cheaper operations compared to the heap, right? So basically, we're looking at just using this GC flags. Then you can easily find that the memory allocation is the most heaviest part for the parsing those numbers in binary numbers into our Go data structures. So what if we try to allocate these memories directly into the stack, avoiding allocating to the heap? So we can just manipulately to conduct these approaches, right? So let's just look again about these examples. There are numbers of represented as bytes on disk, as we've seen before, and we are trying to reparse into the data structures. So the little thing to be differences on the aforementioned examples is about the binary little endian. So we can just use those little endian libraries to directly the parse into a stack using its offset with those having 4 differences windows, right? In that case, like it takes around 600 million seconds for the parsing the 1 billion UNT64s. So which means that we do not like involve memory allocations if we like consciously take into a stack rather than like allocating it to a heap. So you might need to think of like how can we just deal with this the bunches of like the flawed data when working with your like own languages. So I just gave the examples on the Go languages, but like if you want to look into which like databases to use into, then you need to just should like conduct your own like benchmarks about whether there's some memory allocations or whether there is kind of the happiest operations which is not easily like seen under the hood, right? So let's take another examples. So let's say like summing all numbers in the nested array. So we have 26 outer elements and each with 8 inner elements, right? And let's say all data is stored on the disk. So you can just think this nested array, which is represented as some UNT64 with variable like name is data. So you can just think of like, oh, okay, you have kind of data on the disk. And so in order for the loading its like data which is on the disk, then you can just take two like approaches. The first is about like JSON. So when you like try to use its APIs from like OpenAI embeddings or Korean embeddings, like they provide its the output into JSON represented body, right? Because like all bodies using a RESTful APIs, which means that it is represented as a response body into the JSON. But things like we all know about JSON takes really like longer time because it's really space inefficient and the parsing is strongly like heavy because it's really allocation itself is really like operation heavy wide stuff. So according to Revate, like they just took like evaluation on this and they said like it takes around like 2 GB size on the disk, and it took some 14 seconds to sum it up about the with the millions of the numbers itself. So like we can just think about if we can take these approaches with using a like proper buff-wise approaches, right? So let's say about you have like UNT8 length, and it works as a kind of length indicator, so which means that you have you can know about there are more 8 elements coming up. So there are 8 elements coming up, and it's like each element is represented as a UNT32 data type, right? So if you like take each advantages of expressing its data into a binary stuff, then you can just take more advantages in reducing its time and reducing its operations, which may be CPU bound operations, right? So let's take some examples. So let's convert them, the shown binary numbers into a slice of the slice of the slice with a UNT64 data structure, right? So you can just take this like examples of like looping the data and to allocate this the length variables using a little endian libraries. And you might think like this is much like space efficient way to represent this data is much. So like as like we've said, like it takes around 700 megabyte size on disk, while it takes around 300 million seconds in total. So you might think of like this takes some more advantages. Like it's really uncomparable, like according to these statistics, right? So it's about the stories of memory allocations. And you need to do your own benchmark about kind of which part takes a lot of operations on the memory allocation itself. Like otherwise, it's really difficult to just give a kind of appropriate like benchmarks to the people, right? So you have allocated mass slices on the left examples. So as we said, like previous examples is about trying to allocate like massive slice to the variables again. So which could be like improved by just removing its like unnecessary allocations, right? So like you can just like improve more space efficiency by just looping the data without storing itself directly. So you can just save more like the memory locality compared to the last examples. So it is much better to mention about kind of memory awareness because like Go languages have its memory awareness features after the 1.20 versions, which means is that Go languages have like its features to allocate the large heaps on the for its like memory, whether it is if it is expected to use a massive amount of the storage for the binary numbers, then each like Go routines or like other some like executions can just take up its memory spaces within the arena. So like GC happens more much efficient way. So it's much better to take us now if your vector database supports memory arenas or not. So if you are like consider for adapting its vector databases where like Go languages is being used for the main languages. Okay, so you can think like dot product operations is all about the multiplication and additions. Why? Because you might all know about kind of comparing two vectors is about like involving the dot product operations itself. And when it comes to like looking at dot product, they are all about kind of multiplication and additions. So like I'm just trying to just saying about multiplications and additions is all involved for like operating a dot product. And the left example is kind of clear, like mimicking example for representing its like operations under the dot product operations, right? So it's much better to mention that you need to look into kind of the CPU-wise operations when conducting its multiplications or like additions. Like when it look, I just used the Godbolt, which is the website for like looking at its like the compiler-wise operation levels for its like all languages, which is also supported for like Golang and it's Rust for the Java. You can just look into a compiler itself for the massive wide range of languages. And when you're looking at some like operations, that you can just pick this like most MULS. I don't know how can I like pronounce it about it, but it's all about kind of multiplying the low single precision floating point of values. So this like operations also like involving with allocating those registers or 32-bit memory locations. So you can just even make this operation much efficient. So we may take some approaches for unrolling into 8 multiplication and 8 additions with not just some looping itself. And like why they do this? Because they can just use this like SIMD. So SIMD takes some single instruction with multiple data. So you can just optimize this aforementioned operations using SIMD operations. So it means that you can just take single instructions involving with the multiple like operation at once. So it is like a much like efficient way of like conducting your like compilers and the CPUs to conduct much better about its reiterated like operations. So you can just find the multiplication and the addition operations for these 3 operations that I mentioned above. So it is about the AVX programming, but I don't know about AVX programming that much. But as far as I know, like the Intel takes about this, and you can just directly like involve with these operations because like Golang wiki just mentions about it. It's about AVX 51.2, and they have its like libraries, and they like the language supports it. But the thing is like how can we just make sure that my Golang programs to kind of use these instructions, not just using a mere instruction, right? I just want to tell the Golang to use the AVX2 or AVX 51.2 instructions when conducting this like dot product operations or the multiplication or the addition operations, right? So like you need to look into your vector database product, whether it supports like this AVX programming operations. So you can just look into an AVO library. AVO library that helps you kind of to involve with using AVX operations into a Golang library. So honestly, like you can not just directly like code yourself into using instructions because Golang does not support it, but like someone else gonna support, so create this library to connect with those C libraries with the porting library to from the Golang to C. So you can just use these AVO libraries to make sure that your program to explicitly use these instructions. And this is an example of a summing a slice of U into 64s. And you might be better to look into the example of Mailbus. So Mailbus is one of the widespread, well-known vector database product, which is also like compatible with Golang languages or other languages as well. And it is one of the products that has been supported by cloud-native organizations. And so this is examples of how the Mailbus uses are able for building out-to-distance code, out-to-distance like operation code using this AVO library. So it also involves an assembly code using AVS programming instructions. So you might be better to look into how it works, and you need to judge about it when you're looking at some like products to use on your production code, right? So it's much better to look into because like the people in these days are talking about kind of quantization because like embedding itself is also like one of the happiest parts to store in the disk and to calculate during in the runtime inferences. So people are talking about whether we can just reduce its dimensionality from the 10 or around the 10,024 dimensions to the half of Y itself or not or like approximately the 76.8 or itself. And the people are talking about like matricial embeddings, and which means is that you can just like reduce its dimensionality while keeping its like accuracy as much as the original like vector dimensions. And but the thing is, like, you need to look into like whether your quantization method is supported by its this AVX programming wise, because when it comes to looking into a quadrant, which is written in Rust, like product quantization itself is not SIMD friendly. So like this is the reason why I just emphasize on like a benchmark on yourself much on your side, because like all like vector database products are talking about they are the best in the industries and they are the state of the art. But when it comes to looking at each like different use cases, they work and they are concreted with a different approaches, so like you need to look into more. So that's why I'm just talking about this way. So yeah, that was a recap. So there's no like generalized benchmarks. So like you need to look into like how the language works, and it's much like important to find your own like approaches. So that was like my recapping on choosing a vector databases, and let's talk about like disk and the cost. So I created this meme on Instruct.KR의 Discord because like people are talking about vector databases, but under the hood it's all about written in RocksDB, right? The RocksDB is one of the popular like KV's tool, which is initially launched by Facebook, and so imagine like if you have like bunches of the storage supported for the KV's tool, then you can just reduce a bunch of the millions of money, right? Because it's all like represented as a KV's tool. So like other than the kind of like auxiliary like features like rank fusions or which is combining of lexical and the semantic search, then you can find the backbone or the skeleton is the same as using its KV's tool. So we need to talk about kind of how we manage disk, because if you want to use this like RAG itself for supporting a multi-tenancy for the millions of the customers, then you need to talk about how we store this data and how we make sure this data to reduce its cost for the saving itself. So we need to talk about some disks. So I just picked this like diagram up. it talks about kind of the monthly cost for maintaining the 5 billion size of the data with 100 of QPS to be supported. So as we see, like Pinecon, which is one of the enterprise-ready vector databases, but they only like provide in the cloud, not for the open source. They take some around $800 to $1,000 per month. So imagine that you just want to conduct in the POC for like latent customers, or you're just in the stage of the like development or stage level. Then at least like you need to pay for around $800,000 per month, even without finding a product market fit. So which means that you need to make sure that you should like make a painful till like finding your revenues from the market, right? And the other clouds are the same. Like Zillow's cloud, it takes around 500 but like Zillow itself is also a startup, so they are racing for the chicken game. Quadrant itself is the same as well. And the one thing to clearly note is I just brought this like screenshot from the Quadrant website, and they are talking about the minimum requirement for disk is about on the IOPS wise is around 50,000 IOPS. Yes, it's a 50,000 IOPS. So which means is that if you want to borrow this disk from the AWS, then you might end up with like finding yourself that needs to pay for around $500 to $700 for a disk it's alone for itself. So considering like your cloud like budget limits, like it's really difficult to borrow disk itself on the cloud. So I just brought this like screenshot on the right side. So if you want to like borrow the storage size around the 5 gigabyte, then it costs. So the old standards is based on the EP2. So you might think of like multiplication of the monthly cost with the storage cost. It takes around the millions of the costs. Like even though you might feel yourself to be very exhausted, right? So. People are talking about also on kind of random access. Why? Why random access? Because, people talking about like approximation approaches when conducting this vector database search. Why? Because like conducting for like brute force search, which also like means as some kind of KNN search, is very painful if you have a bunch of millions of documents. So you need to conduct with quantization along with approximate search. So approximate search means that you need to reduce the vector database space search. Then you might be able to approximate these the operation costs rather than taking a whole bunch of the brute force search. So when it comes to Quadrant Discord, they are talking about like using HNSW, which is some hierarchy random small world, take some random access itself. Why? Because like creating its like graph and creating its small world for the runtime inferences, it takes some bunches of like operations that you need to do on conduct and random access. So even although like they support an index, like we cannot assure that whether there's your small world can be already like indexes before, because users' queries are every day different. So like they might like conduct a lot of random accesses. So you might think like random access itself is very slowest operations like involving with the disk. So like people are talking about this one. So this is really important now to think of whether like this, how can we just deal with disk is very like one of the sophisticated operations when like managing this rack. So let's just reiterate about these Hacker News articles, and its title itself is about like supercharging the Discord network disk for extreme low latency. So how they conduct these approaches? So as is for the Discord setups, they have a persistence disk with a read-write mode on the Google Cloud. So they have some like 1 or 2 milliseconds latencies for disk operations, like kind of writing or like kind of writing operations with a timeout. So they just propose a setup for prioritizing the read performances, for write performances about the service speed, and they like accomplished this this goal with using local NVMe. So which means that like they just try to separate this read operation, the wise disk, which is take some read local NVMe, while they just introduce another dedicated persistent disk for like ensuring the data stability. So when it comes to like picking this lessons up, just you can just look into validated tree lemma. I just created this tree lemma for making sure you can just understand about offsets or something you should lose for taking other advantages. So you can see this triangle that expresses the latency and low RAM footprint and accuracy itself. So I just put the on-disk mode as a low RAM footprint and accuracy, which you can take them all while losing its latency itself. And when it comes to like in-memory mode, you can take latency and accuracy, while you need to pay more about the RAM footprint about using this mode. So I just want to share this calculations about the three modes differences. So the first mode about in-memory mode, we can just intuitively guess that its in-memory mode takes around the most efficient time compared to the other modes, right? Because in-memory takes some more speed, or rather than just conducting on disk overhead. So it is proven by this statistics that I'm just now showing to you. So when it comes to in-memory mode, you can take creation time from around 100 milliseconds, while disk mode takes second half or second more, around the third more fold itself compared to its previous in-memory mode. And so the take-up itself is about, well, you can just creating new documents or creating backups. Snapshot means backup, much efficient compared to disk mode when if you decide to want to use in-memory mode. But the thing is taking is borrowing is RAM storage focused machines takes more can take a more cost, or it's maybe bound or hindered by your budget constraints. So that's a kind of old thing, right? So you can just introduce this approaches using a tier storage. Why? What is tier storage? So basically, you can just manage your data according to some conditions that you can just predetermine. For example, if you say if you have a tenancy, or if you have a customers that uses a lot and they pay takes around the majority of your business revenues, then you need to consider these customers for more much important to the other customers as well, right? So in that case, you can just assure that their data is loaded in much faster way than the other customers, and you should assure more stability for that customers compared to other low tier customers, right? So you can just put this first tier. I just say tier 0. Tier 0 mode for its storages. So which means that you can just use them in memory mode. So you can take on more cost about using in memory modes, but it might say that it involves with much faster read operations considering its business constraints. And you can just take high IOPS for the tier 0, right? And you can just look into the other tiers for you can just say, we have a balanced performance for mid-level customers. Then you can use a mid-level IOPS disk, or at the bottom, I just say the tier 2, which is mean that you can just put your storage to your S3 compatible storages. Yeah, S3 uses a hot disk, right? And I just I can just put this data into tier 3 storage with saving more cost but it involves with lots of the overhead. But it's okay because like your customers are still satisfied with your business options because they pay less. And if you say like they are or like access with really lower time frequency compared to other customers, then you can just put your put their like data into a much like lower tiers, and you can just say that you can just optimize like performances and it's cost efficient for the operation when just implementing those tier storage approaches, right? And I just would like to introduce this trilemma for the RAG service itself. So basically, like if you want to like kind of like implement those like one collections for the per one customers, like which means that the vector database itself tries to minimize its memory usages by like avoiding border creation of many small collections. But instead, like data could be very segmented within the single large collection because they have a metadata filters, which is very like important features to the filter by the specific the values, not just rather than just using lexical or the smartest searches. So which helps you to reduce more memory footprint. So which is required via embedded vectors. So like you need to create more like strategies to maintaining the total numbers of collection much smaller rather than creating for like collections for one collection per one document or one collection for one customers. Like you need to think more about approaches to reducing its collections. So when it comes to like the performance itself, like creating it's like multiple like collections per customers as which can vary like unwise approaches because it can lead to performance degradations because by grouping the data into a single collection as mentioned above and using a multi-based like segmentations like the vector database tries to minimizes the number of collections or the duplicated data segments. So like you need to look into whether your vector database strategy is supported for like this optimizing its data segments. But in the most of time, creating more collections would like degrade your like performances for retrieving itself because vector database needs to take more approaches for like maintaining segments. So it also like takes kind of the problem of scalability because like if you have like single collections with like having different filters that you can just look into whether this data is for each sub-customers or this data segment is for the other data customers, then you can just filter by its like collections. So you can just maintain more scalability by reducing its duplicated data storage approaches. The next thing is about operations. I was in San Francisco in last June. And I just one of the like the honor to take this Perplexity's lectures about how they like maintain its like production rack systems because I just one of the users of the Perplexity AI rack because yeah. I subscribe to SKT Telecoms and they provide a 1-year premium membership for free because they have their business collaborations. So I personally use the Perplexity Rag a lot, and also I just like get curious about how they like maintaining millions of like traffics or across the globe, right? So we just try to took into approaches for inspecting how the Perplexity works and how like other data engineering platform works, and we just try to come up with structures that tries to create the vector database for each different tenant for the dedicated one. So this is how we maintain the RAGOps systems within under the hood. So we're trying to build this systems within the Golang using Golang for maintaining its metadata and maintaining its how the life cycle of vector database is. So the one thing to clear is about we are trying to create its dedicated vector database for each different tenant. So it could be very volatile. So this works with the session-wise windows. So if you access into a specific website, then this vector database opens up for the groups of the tenants that have been accessed into the website for a specific period of time. And this period of time is also managed by our management services, which is built in the Golang as well. And we are trying to maintain this metadata using Redis. So it takes some kind of your IP address or whatever is identifiable, some text identifiers like IP address, or it could be a user ID, or it could be other email address as well. But we are trying to group these tenants into a single tenant so that they just mapped into a vector database itself, and each vector database lives within the certain period that has been predetermined, and this life cycle is managed by using Redis and then its Golang services. And so if you think you can just you can determine the maximum number of the vector database which is on our clusters, and if you think that you need to conduct more allocations for creating the vector database, or it is not needable as much, so you can just, if you decide that you can just delete our existing vector databases from the clusters, then we just determined our workflows on using our Argo workflows, which is also for written in Golang, and they are really cloud-native platforms. So we're trying to automating this management and deployment of pods across the different stages of the cloud. So this is our a broad diagram of how it works. So basically, the managed services, it has some KB map which is written. It's a really route itself, and they just trying to manage those multiple vector database instances within the clusters, and they try to map to the existing users with certain metadata stored on the Redis for the first place. So I just wanted to give kind of examples. I'm using standalone examples so I just try to write these examples up using a calendar event libraries. So you can just disconnect the quadrant event. So quadrant is one of the vector databases we use under the hood, and you can just designate the quadrant event as a type and a struct. So you can just say that the service itself has the available pool and available agent. So agent means that it's different customers, right? So there's available pools, available customers, and you can just designate the dispatcher. So you can just add it to a map your newly registered customers on the perspective of sessions and to the map into an available pool, and you can just publish this event. Then it's other other services still subscribes on the event that has been emitted because the new customers registered sessions, and they just try to map its customers into a vector databases. So you can just look into get available pool. So if you see that your the number of pool is still available when it comes to looking at the numbers of incoming traffic and incoming newly created sessions, then you can map with the session ID or other identifier with existing the pool's URLs or whatever is identifiers. So this works as kind of a proxy under the hood, connecting those session IDs as input, and the output should be kind of URL of vector databases, so that the customers of this managing vector their services can look into whether this agent, this customers should use which like vector database instance itself. And they are basically like replica, so they are like sharing the same type of instances and sharing the same type of metadata or the configurations while they are different paths under the hood. So the key is about kind of allocating the agent. So you can just range the for loop about the available pools. Then you can just allocate it with the key or value. So that's a KV store, right? And you can just the response to the customers or response to the subscribers, right? Yeah. So as mentioned, so this is kind of really like skeleton of the examples. I just written for the examples for today's talk. So in summary, like this managing services we have under the hood using Golang and Redis and Vector for KV store for manages the pool for like managing the available Quadron instances, and it's like it takes some responsibility for assigning those instances to the newly created agent. So when the services decides to creating the new instances is required, then they create the pods using Argo workflows, and the workflows like returns the callback, then the trigger the predetermined like endpoints of the services. Then the endpoint understands the health check, understands whether this pod is alive, whether after conducting a health check or other related the operations. Then the pool is added to the KV store for the sake of being the pod itself is ready to be allocated to the newly created customers. So I just try to use this event listeners to make sure that this service itself works as asynchronously, like doing a logging or doing a more like additional operations specific for these examples. So last but not least, you need to look into how you can maintain its SLAs, because there are unexpected, like chaotic events can be occurred across your life, right? So in that case, like you need to make sure that you have a chances to back up and restore to the specific timeline by periodically capturing each snapshot. So like we're just trying to implement those like pod and the PVCs, which is like also like assigned into a Harlem chart. So like PV itself is bounded to the PVC, and we just mount its PV to the mounted to the pod. So our initial the context is that if your customer requires like replaying or re-rolling the pre-existing chat or sessions itself, then you need to restore right away if the session enters into website and some signals are triggered to the managing services. Then we just look into which agents identifiers are mapped into the specific disk or specific snapshot files, which can be uploaded on the storages, as I mentioned, using a tier storage strategies. Then to back up, just download this file and automatically back up to the sessions so that customers can headlessly access into the sessions that they have talked before. So if you just look into on the ChatGPT website, so if you just click on the left dialog, which shows you the history of the chat, then you can just take around 1 or 2 seconds. Then your previous sessions comes up, and you can just try to replay your sessions or continue your sessions. And we're trying to implement those features by periodically capturing the snapshots and backing up the clusters and restoring the snapshots if the customers wants it and they give us signals to the services. So for summing up, like these operations takes lots of like custom to controlling or operating operations. So we're trying to kind of wrap these sophisticated operations using operator pattern in Kubernetes. So as you seen a lot from in the references or the presentations, that Kubernetes operators are customized resources that you can predetermine for yourself, or watching the specific actions, watching the specific behaviors happen on your clusters, happen across your pod life cycle. Then you can just update and you can just watch it manage the object itself, because you just specify the manage object, and then they manage the object have a specific fields to emit its event. Then you can just have customized control loop to watch and update and manage itself. So. Yeah, that's kind of one of the examples of it. So we're trying to implement those like operators for like maintaining quadrant activated databases, and not only for the backdoor database itself, but like you might have dedicated document parser or like specified auxiliary like utility servers as well. Then if you say like this, if this is like whole the objects are like wrapped into a single pod, and if this pod is should ensure itself for a life cycle as a whole. Like for example, like if your document parser has become unhealthy and unresponsive, then you should determine whether this document parser should to be killed and reiterate itself till it becomes responsive again. Then the operator can like take these approaches, because if you're not using operator, then there are no way to look into a specific containers like health check on the pod. But whether if you have specified like customized objects, and if you like determine your own the custom object, then you can just check your health check for the specific containers within the pods. Then operator can understand whether the specific object is unresponsive. Then you can the service itself try to make this responsive again. So you can just ensure its stability of the features across the customers. So we are trying to implement those like features, because we just try to wrap some plethora of services into a single pod, because they are basically like microservices, and they should like to be a replica of each dedicated customer. So we need to determine the operator itself. So these examples that I show about the operator SDK, so like you can just use this library for creating your operators. So which means that you can using a Golang or Python for designating or creating your own the operators. So you can just take a simple like example for declaring the minimum number of the replica or the maximum number of replicas. So this is a really rare, mere example. And you can just specify which container images that you can just use for it. Well, you can just use this like features in just using a deployment spec, but like you can just imagine whether this example can be very widened when not just using a replica itself, but also like looking at the specific containers of the pods, right? So you can just determine the observed state of quadrant, which is some vector database as well, and you can just look into a specific nodes, specific like replica set of this quadrant, and you can just determine the expected behavior of these customized resources, and you can just determine what action should be executed after finding that this predetermined signals and predetermined paths are not unresponsive according to your designated behaviors. Yeah, that is kind of controller, so that you can just setting up with the managers. So like on the examples, that is setting the kind of all the references to the custom resources and check if the deployment exists or not. And if not, then you can just create it, and this reiterates every time. And it is managed by your Kubernetes controllers, and you can just try to reconcile these resources as you shown above. So yeah, so you can just apply to your CLD and apply the manifest to the clusters. Now this is the whole life works. So Basically, like I just wanted to share about kind of a mere the helicopter views of like managing those like operations for implementing the RAGOps systems after the applications. So it is about much akin to a traditional like DevOps singing rather than about kind of modeling or machine learning models or fine-tuning stuff. But the thing is, like the really the lack of the human resources that has been taken up with managing those clusters or on-premises or cloud or like ensuring the SREs to the ML world, because like they are. I think they are being kind of little connections with those AI worlds. So AI world has lots of like demands for employing and taking its advantages with SREs or traditional like DevOps systems, but people and DevOps infrastructures are relatively reluctant to change themselves into AI or LLM world. So I just want to encourage yourself, if you are DevOps or if you are very familiar with Kubernetes or like working with like traditional disk, then you can just try to yourself to challenge to a RAGOps world, because like people are in here are really like feeling the lack of like human resources, so we need to hire more, right? So I just want to share it's like on the possibilities of like looking at to offer career positions. So if you're interested in this talk about this or these agendas, then I just want to encourage yourself to explore this career website to look into more. Thank you.